basic mathematics in Python. Okay. The Python GUI can be used to do a lot of mathematics. It's kind of like, well, MATLAB if you have used before, but it has a lot more functions. Well, I prefer Python to MATLAB because it's free. Well, but yet, no matter what, this is not a replacement for a scientific calculator, because otherwise you'll have to carry your laptop everywhere you go. And to start with, the most basic mathematical operations we come across everyday life is the plus or the addition, subtraction, division, and multiplication. So let's see how these four are done in Python. Uh, if you want to add two numbers, well, these can be as variables. Let's say a equals 10, b equals 20, okay, and c equals 7. So what I'm going to do is I'm going to add two numbers, or actually add two variables. So what I'm going to do is I'm going to say a plus b. So a plus b is 30. As you see, a is 10 and b is 20. So when you want to add two numbers or variables, what you use is the plus sign. So you can even use two numbers like 10 plus 60 is 70. So because in programming, why I'm using these variables is that you will very rarely come across programming that involves direct numbers. So it will be more like input arguments that come in variables, not in numbers. So each variable have a value which is a number. That's why I'm using A, B, C over here rather than just numbers. So subtraction can be done the same way. Let's say A minus C will be 3. Okay, right. So division, we use the slash sign. So if you want to divide A by C, it will be 1.43, almost 1.43. And there's a bit of a difference about Python 3 plus versions and Python 2 versions about this division. Okay, so if we go once again, we have 10 divided by 7. So we have two integers divided, we are getting a floating point number as an answer. Now I'm going to open Python 2.7 for you just to show the difference. Okay, don't mix them up. Python 2.7, or well, two versions of 2 are different from this. So if you divide two numbers like 10 divided by 7, the answer will be 1. Why is this 1? The reason why this answer is 1 is because the two numbers we have given, that is 10 and 7, are both integers. So the interpreter or the compiler of the Python shell thinks that well, if these two numbers are given are integers, what I'm going to output is an integer. So 10 divided by 7, it will be 1, and well, I guess it's 3 over 7, right? I guess so. Yeah, it looks like that. And what it does is it takes the value and takes the flow of it, or the next smallest integer. So 10 by 7 is 1.42. The integer that is smaller, that is well, a step before it is 1. Actually, I don't know the exact terms for this because I learned in Sinhala. Okay, so well, I'm sorry about if I'm using the wrong terms. So, and in version 2, if you want to get a similar answer, what you need to do is you have to give a floating point number either to one of these. Well, let's say I want to divide 10 by 7.0. 7.0 is a floating point number, then it gives the same answer. Or if I want to divide 10.0 by 7, yet it gives the same answer, but not with 10 divided by 7. So this is called integer division. A lot of programming languages have it, but for one reason or the other, Python has removed it. Well, kind of good though, because when you divide something, you expect a right answer. So that's about division, and if we look into multiplication, we can say A into C is 70. Okay, and although I didn't mention, you can raise A to the power C, so it's like A using 2 asterisks into C is some big value. Okay, and just if you want to understand it like this, if you want to 4 to the power 2 is 8, sorry 16, bad maths, and 4 to the power 3 is 64. Okay, so if you want to raise something to the power of something, use 2 asterisks. And you can also negate a number. For example, if you have plus 10, that is A, you can say Z is equal to minus A, where Z will be minus 10. Okay, so negation, what you do is you put a minus sign in front of the value or the variable that is over here, and the result will be negated. And also we can look into the absolute value of a variable or a number. Let's say ABS. ABS stands for absolute, and we are going to give the number which is Z, and remember it's 10 over here, and the answer will be plus 10. So that ABS will give the absolute value of a variable or a number, and it comes quite handy when you do go some high level of programming. Okay, so other than that, you need to look into the square root. Okay, so how do you get the square root in Python? You can't get it straight away. You need to import a module. Remember last week, last lesson we talked about importing modules, like using the import statement. So what I'm going to do is exactly the same. I'm going to import math. Math is the name of the module. It comes with Python, and once I import math in this script, I will be able to use math as an object that I can do mathematical operations with. So just first let's see math.sqrt, and let's say for it says name error, name math is not defined. It's because we have not imported the math module. So over here let's import math. Okay, and let's do the same thing. Math.sqrt is 4. So the answer is 2, and math has a lot of functions like math.flow, and you can say 4 divided by 3 will give you 1. Math.ceil, I guess. Oops, math.ceil. You can say 4 divided by 3. This should give 2. The ceiling and flow. Well, when you're in between two integers, the ceiling is the higher value of it, and the flow is the lower value of it. And remember in Python 2.7 or those 2 versions, you got integer division, and you can get kind of the same result over here. Let's say you want to divide 4 by 3 and get a similar answer like in Python 2.7. What you have to do is you say math.flow 4 divided by 3, which is 1. If else you get is 1.33. Okay, kind of the same over here. So if you have some older code, well, you can use this flow function to make it compatible with version 3. And well, I guess that's it. Let me look into the slides for a while. Okay, I missed one. It's a modulo. Did I talk about the modulo? Nope. Okay. What's a modulo? Well, if you divide 2 numbers that don't divide evenly, there is a remainder. For example, I divide 4 by 3, it's 1.33. Okay, so there's a remainder of 1. That means when you divide 4 by 3, the result will be 1. The remainder will be 1 over 3. So 1 is the remainder. So how do we get this remainder is by using the modulo sign. Let's say 4 modulo 3 will result 1. 5 modulo 3 will result 2. So the remainder of the remainder of an division is given by the modulo sign. These are some of the useful mathematical operations that you will come across when making Python programs. And there's also something more useful about comparing numbers, comparing things. So let's look into that as well. When you compare two things programmatically, it can be equal, one can be larger than the other or smaller than the other. Well, in short, it can be not equal. And when a condition meets, it will be true. For example, if I say 1 is equal to 2, 1 is equal to 1, it says true. So the equal sign comes using two equals. So over the slides I have it over here if you want to see them. Equality comes with two equals. Greater than sign is, as usual, it's a greater than sign. Smaller than will be smaller than, as usual in maths you learned in school. And not equal to, we use a exclamation mark and an equal mark. So those are the ways you compare numbers. This comes quite handy when you use if statements that we'll discuss to the latter side of this lesson. And if I say A equals B, it will be false. If I say A is larger than B, because A is 10 and B is 20, it will be false once again. If I say A is smaller than B, the condition is true and the output will be true. Okay, let me just peep into the slideshow and see what we have next. Talked about comparisons. Okay, it's about container data structures. Last week we talked about strings, integers, and floating point numbers. And containers are a little bit complex because they have the ability to hold multiple types or even multiple data structures within themselves. Hence we call them containers. There are three types of container data structures in Python: lists, tuples, and dictionaries. Lists are kind of dynamic stuff, very flexible to work with. They are mutable. In other words, you can change them. For example, once created, you can add things to it, you can remove things from it, you can sort it as you wish, and you can, well, extend a list by adding another list to it. For example, if you add list A to list B, you'll make one big list which has all the elements in A and all the elements in B. And also you have facilities to insert and pop in the sense you just remove the last item of it. And how we make a list is using these square brackets, and within you have its items separated by a comma. Over here what I have are strings, that's why they are in quotation marks, and if they are numbers or any other variable, you can just have them without quotations. So just let's go to the Python GUI and have a little bit of fun with it. And okay, so I'm going to define our first list as my list. Okay, list 1, that's better, equals, I'm going to add some names. Okay, so it's going to be Zian, that's me, Amit, one of my friends, and Roshan. Right. So once I hit enter, the list is created. If you want to see it, we can just type list1 and it shows its elements. The first thing that we are going to do is we are just going to access an element of it. So what we do is this list is like an array, and each of these items have an index. Okay, Zian is the first item over there and its index is 0. And Amit, which is the second, has an index 1. Roshan has the index of 2. Remember, it doesn't start with 1, 2, 3 likewise. This first element happens to be index 0. So let's say list 1, you open square brackets and you enter the index number. For example, 0, we'll say Zian. List 1, 1 will be Amit, and list 1, 2 will be Roshan likewise. So the list index starts with 0, not with 1, just keep that in mind. And if we want to add an element to this, let's say list 1 dot append. What we're going to do is we're going to add a object to it, which is, let's say, PL. Okay, that's another friend from school times. And once I say enter, I'll have list 1 with Zian, Amit, Roshan, that's the original list, and PL appended to the last of the list. So now we have 4 objects, and the index are like 0, 1, 2, and 3. Okay, so I'm going to write another list. Let's say list 2, and it's going to be well, let's put some girls' names: Amaya, Shireen, and well, I have to select some names that don't get pissed off by this. Roseanne. I hope I spelled her name right. Okay, I'm very bad at spellings, by the way. So I got now 2 lists, and I'm going to join these 2 together. Something happened. Well, how we join 2 lists together is using the extend command. So I say list 1 dot extend, and I'm going to give list 2 as the argument of it. So I'm going to extend list 1 with list 2, and list 1 will now have the set of boys and a set of girls over here. And that's about the extending of a list. And also comes quite useful is the sort command. So what if we want to sort this list? So I'm going to say list 1 dot sort, and just it. Okay, no arguments given. List 1 dot sort will sort this ascending order. And if I see list 1 once again, you see everything is arranged in an ascending order. Thereafter, if I want to sort this the descending order, I have to give an argument and say this has to be descending. So I'm going to say list 1 dot sort, and I'm going to say reverse equals plus true. Okay, so if I check list 1 once again, you see on the previous prior to sorting it in the reverse direction, I was the last, and now I am the first. So it's ordered in the reverse direction or in the descending order. Well, if you're kind of curious what type of functions these things have, you can just put its name, list 1, and press the dot and wait for a while. It opens up a list of options or list of functions it supports. Okay, over here we have append, that is to join 2 lists. We have count, okay, that's also interesting and useful. We got extend, we got index, insert, pop, remove, reverse, and sort. Reverse, what's that? Okay, just let's see what reverse is. Kind of interesting. Okay. Looks like it reversed the order. Yeah, list 1 dot Yeah. Okay. So over here, I reverse the list, and well, the previous one was arranged in the descending order or the index wise. It's not a sorting operation, it's rather taking the first element and placing it in the last, the second to the one before last, likewise. And when you do it twice, you get the same list once again. Okay, this is the same. So it's not a sorting operation. If you want, you can check it out separately. It's just changing the indexes in a way the first becomes the last becomes the first, likewise. Okay, so we got the reverse operation, and if we look into the others, we got count. Okay, that's something interesting. uh, I'll just add another item for this. I'm going to say list one dot append, and I'm going to say Xian. Okay, and let's look into list one once again, and I'm going to sort this dot sort. Okay, spelling mistake. List one dot sort, and if I say list one, okay, now I have two Xians over here. What the count function does is it counts how many occurrences a keyword has. For example, if I say list one dot count Xian, it will return 2. If I say list one dot count Pial, it will say 1. If I say list one dot count Mahinda, well, that was one of our ministers or the president is going in a chopper right over our house. Sorry about the interruption. That's why I put Mahinda Rajapaksa is the president in Sri Lanka. It says 0. It's 0 because we don't have a Mahinda over here in this list. Okay, so likewise the count operation comes handy. So that's about counting. And list one dot, let's see what else interesting things you have over there. Remove pop. Okay, now when you have a list, when you pop an item, okay, if you consider this the list, which is when I pop something, what happens is it takes the last element of it and returns the value while remove it from the list. Let's just check it out. List one dot pop, and I'm going to say nothing because I'm supposed not to give anything, I guess. You can even pop an index, but that's compulsory. Not compulsory. If I say pop without any argument, what it will do is it will remove the last element in the list. Okay, so let's see. It says Xian. Okay, so what it did was it removed this last element and returned the value to the user or the program. If I say val equals list one dot pop, and I give an index this time, I'm going to remove Amit from the list, so I'm going to say 1. So Amit is index 1 over here, and if I say list one dot pop 1, it should remove Amit, and that object should be saved in val. Okay, so let's see. I'm going to say list 1, and see Amit is not no more in the list. And if I look into val, there he is, Amit. So what the pop does is it removes an item and returns it to the program, and the list gets shortened by 1. Okay, that's what's most interesting about lists. And hi, I'm back. Well, we've had to talk about tuples. Last we talked about well, lists, and when talking about tuples, they are very immutable, or they won't change after you implement them. For example, if I say tuple 1 equals, the definition is given using brackets, and let's say you're going to give some values. For example, I'll say Xian Pasindu and promote. Okay, and when I press enter, a tuple will be created with the name tuple1, and I can view it by saying tuple1, and you see Xian percentage promote is in the list. Okay, sorry, the tuple. So if you want to check out what type of functions they support, you can just use the dot and see what the menu shows up, and I'm going to do exactly that. Tuple1 dot, as you see, it shows only two options, very limited functionality. It shows a count that I can enter a value. Let's say I'm going to say Xian, and it will say the number of occurrence of this keyword or this value in the tuple. So I'm going to say tuple.count Xian. It will count how many occurrences this string or this object has occurred in the string and return that value. So that's about the count. And there's also a tuple1 dot index option that you can say you can get the index of a value. For example, if I say Xian, it'll return 0. If I say Pasindu, it should return 1, and if I use promote, it'll return 2. So talking about tuples, tuples are immutable. They don't change after creation, in the sense you can try to add something tuple1, let's say I have 3 over here, so I'm going to say 3 equals alpha. It says type error, tuple object does not support item assignment. Okay, so if you try to add or change this thing, you cannot change it because it's kind of immutable. And why do we have this type of things? Well, tuples turn out to be kind of fast relative to lists. Lists that we talked about in the last section. For example, list1 equals, you say, something, and that is because, well, lists support a lot of functions and they have to have space for expansion and likewise, but tuples are kind of static, and they also are claimed to have consumed much less memory, or kind of less memory, than their counterpart list. So if you're having to do a program using list and tuples, if the data ain't going to change, I think it's best to use tuple because they have a performance as well as memory gain or efficiency than lists. Lists are much more dynamic, but there is an overhead. So what you use depends on what you really have and what you really need, and use wise programming skills and things should be fine.